Welcome to Lesson 06, the one where the migration finally pays you back. Up to now, this whole journey has been about compliance. Distros deprecated iptables and you followed. But this lesson is different. We're looking at 5 primitives: sets, maps, vmaps, meters, and intervals that iptables literally could not do. 80 rule sets collapse into 5. One set plus one vmap becomes your entire ingress logic. This is why you migrated. Here's the map of what we're about to unpack. Sets replace the endless IP list rules with kernel-native hash tables. Atomic, interval-aware, auto-timing out. Maps and vmaps collapse if-else branching into a single lookup line. Meters give you named, queryable rate limits where hash limit gave you pain. And intervals plus concat let you match things ipset literally couldn't, like an IP and port pair in one expression. 5 primitives, 70 to 90% fewer rules. Let's take them one at a time. Before we dissect each primitive, look at where we're headed. Same policy on both sides. Office subnets get SSH. The world gets 80 and 443. New SSH is rate limited per source. Everything else is logged and dropped. On the left, 60-plus lines smeared across iptables and a separate ipset config. On the right, 1 table, 2 sets, 1 chain, 5 rules. Every decision visible in a single screen. That's the payoff. Now let's see how it's built. First superpower, sets. 3 flavors, each retiring a different iptables workaround. Simple sets replace flat ipset lists with hash lookups. Interval sets store CIDR ranges natively, something ipset's hash.ip never could. Timeout sets auto-expire entries, so your fail-to-ban glue and cron jobs just disappear, and you can combine flags, intervals with timeouts, banned subnets that evict themselves. Atomic updates, queryable state, O-log-n, lookups instead of walking a chain. Superpowers 2 and 3, maps and vmaps. Maps hold key-to-value pairs. On the left, a port-to-backend lookup that turns 3 DNAT rules into 1, and adding a 4th backend is a single-element insert, no rule reload. Vmaps go further. The value is a verdict. On the right, port-based dispatch jumps to the right chain via lookup instead of 4 sequential matches. Branching becomes indexing. The kernel does the work. Superpower 4, meters. Remember wrestling with hash limit. The burst flags, the mode strings, the named buckets that silently collapsed under load? Gone. 3 lines. Name, key, rate. The kernel tracks state per source IP, and you can list it live to see exactly which addresses are pressing against the limit. And when an offender overflows, pipe them straight into a timeout set. Instant auto-ban, expires on its own, no cron, no user space daemon. Superpower 5 is really 2 primitives working together. Intervals let a single set element be a CIDR block or a port range, so 3 RFC1818 networks become 1 set, not 3 rules. Concat goes further. You match a tuple, source IP and destination port, against 1 lookup. That's the IP set with bitmap and hash mess from iptables, collapsed into a declarative table. And drop concat into a vmap, and you've got multi-key dispatch, the right chain for the right pair in a single kernel hop. Step back from the primitives for a moment because the deeper win isn't any single feature, it's 3 structural shifts that compound. First, you represent knowledge as data, not rules. You stop appending lines and start adding entries. Second, updates are atomic by design. 1,000 changes land in 1 transaction, or none of them do, with no half-applied window during deploy. And third, operational visibility is built in. Which IPs hit the rate limit last hour? Stops being a TCP dump grepok pipeline and becomes a single NFT list meter query. So here's the cheat sheet. Print it, tape it to your monitor, and pull it out during step 3 of the L05 workflow. The pattern is always the same. Spot the smell in your auto-translated output, then reach for the matching primitive. 5 rules with different source IPs becomes a set. An if-else chain of jumps becomes a vmap. Hash limit becomes a meter. Source and port pairs collapse into a concat set. Each row is a rule sprawl reduction you can quote in a code review. Theory's done. Now you earn it in your hands. 3 drills escalating in scope. First, 20 minutes. Collapse 5 subnet whitelist rules into a single interval set. Then prove the operational win by adding a 6th subnet without touching a single rule. Then 30 minutes on port dispatch with vmap, replacing a chain of jumps with 1 declarative lookup. And finally, the headline drill, 45 minutes building production-grade SSH brute force protection with a meter feeding a timeout set, hammered with Hydra until you watch offenders appear and self-delete in real time. Before you go refactor production, 5 traps to internalize. 1. A set declared as IPv4 adder but queried with IP6 satter will silently never fire. Match the type exactly. 2. Don't convert and refactor in the same commit. When a packet misbehaves, you won't know which change broke it. 3. A 2-element set is worse than 2 rules. Sets earn their keep at 5+ stable entries. 4. Vmaps past 15 entries go opaque, split them or jump to per protocol chains. 5. A meter without an overflow rule just drops. Pair it with a timeout set so you track offenders, not lose them. And that's the payoff. 5 superpowers fluent, 60 rules collapse to 5, a decision matrix you can pin above your desk, and the traps mapped before you hit them. The migration just paid for itself. Every line you write from here is shorter, faster, and easier to reason about than what it replaced. Lesson 7 turns this into the 8-stage playbook your team can actually ship. Inventory, translate, refactor, review, stage, deploy, verify, archive. See you there.